Hey there, Geometry Cats! Today we're going to look at 2.5 Reasoning in Algebra and Geometry. Now before you say, Mr. Twiller, I passed Algebra last year. Guess what? It never ends. Anyway, we're going to learn a bunch of properties today, and we're going to learn about two-column proofs. For some of you, this will be awful. For many of you, this will be awful. For some of you, it won't be bad, and I'm going to try to make it as nice as possible. We're going to make our proof toolboxes tomorrow and start getting those loaded with the tools we need to be successful. Sorry guys, I had to change location. Life was happening in my kitchen, and so I had to leave. Alright, so let's just go through it and complete this graphic organizer like the instructions so nicely ask us to do. 1, 2, 3, 4, 5, 6, 7, 8 properties to learn, and you're going to use them all the time. First one let's look at is substitution. When you're tired, they call us I'm just kidding. Okay. This is a tuition that a sandwich pays to get into college. A subs tuition. Alright, that'll seem worse. So if A equals B, then B can replace A in any equation. And you do that all the time. Do you know when we solve for X and then we plug it back in? That's substitution property. Alright. Multiplication. If A equals B, A times C equals B times C. And you do this all the time. If you have some equation like x over 2 equals 3, and you times both sides by 2, that's the multiplication property. You can multiply both sides by the same number. Right? Right? Yeah, you can. Alright, next is division. Same thing. A equals B. You can divide both sides by the same number. 2x equals 6. Divide both sides by 2. But C cannot be 0 because you can't divide by 0. Go ahead and ask Siri. Go ahead and ask Siri. Go, I'll wait. Alright. The transitive property. Transitive property. No, I know it says transitive property. Alright guys, I keep pausing this piece. Alright, transitive. If A equals B, B equals C. If A is connected to B, B is connected to C, A is connected to C. You guys do this all the time. If I tell you, if you work for an hour, I'll give you 20 bucks. And then I tell you, give me 20 bucks, I'll give you a gold bar. It means 1 hour works worth a gold bar. I don't know what kids like anymore. Symmetric. That means symmetric symmetry. You cut it in half. It's equal both sides, right? If A equals B, then B equals A. That one's silly to me. I don't know. Reflexive's worse. Reflexive means that A is looking in a mirror. Do you want to see his back at it? Another A. A is equal to A. Hey! That makes sense, kinda. Addition property. If A equals B, if I add C to one side, I can add C to the other. Same as subtracting. Again, if you have 3x plus 1 equals 5. Have you been subtracting 1 from both sides for years? Yeah, you have. You just haven't been calling it the subtraction property of equality. Alright. You guys ever heard of the distributive property? You haven't? Well, looky here. Distributive property says if you put something on the outside parentheses, it has to distribute a paper to each of those. They each get an A. You get an A, and you get an A, and you get an A. Okay? And if you subtract, you still distribute it. I don't know why there's two different formulas. This is how it is. Alright? So, for example, and this should all be reviewed for you guys. If you have 4 times x minus 2, you guys know that 4 is going to deliver a paper to each of these guys. And you're going to get 4x minus 8. Alright? Distributive property. Love it. At least learn it. You don't have to love it. What's the value of x? Justify 8 steps, see? Alright. I will. Given AB bisects RAN. Make a two-style proof. Call it steps in reasoning. Here goes nerfing, guys. First, two-column proof. First step, AB ray bisects angle RAN, so far away. Reasoning, it's given. You always put your given first. Every single time. Alright. What's it mean to be a bisector? What do you get to do? What's a bisector do? Could you say that these two angles are equal? You can. You can say the angle. Where am I going with that? Angle RAB is congruent to angle BAN. Ray-ban. Because definition of bisector. Angle bisector if you want to be specific. Oh, this is where these get silly. Alright. Whenever you say two things are congruent, then you have to say that their measures equal each other. That's the definition of congruence. I'm sorry, this is really talking away. I don't like to talk. Alright, let's keep going. Alright, now we know those angles are equal, and we have some x's here, right? So I can substitute x in for rab, right? I can say x equals, what's ban equal? Well, that equals 2x minus 75. That's because of my substitution property of equality. Again, because rab equals x. So I can interchange them. And because the measure of ban equals 2x minus 75. So I can substitute them in for each other. Oh, man. So now let's solve this beast. Do you want to subtract a 2x from both sides? So let's subtract 2x. And I end up with negative x. It's negative 75. So I subtracted something from both sides, right? That's my subtraction prop of equality. Now I have a negative in front, so what do? I can multiply everything by negative 1. I get x equals 75. Because I multiply both sides, that's a times negative 1. That's my multiplication prop of equality. Done! First proof! Woo! Exciting. Alright, when we look at these properties of congruence, we have the reflexive, symmetric, and transitive, alright? And now those properties are the exact same ones we learned for equality. The only difference is, with congruence, we're talking about not numbers, but actual physical things. So equalities for numbers, this is for actual physical things in geometry. But they're the same properties. Alright? Reflexive is angle A is congruent to angle A. Symmetric is if A is congruent to B, B is congruent to A. Alright? Transitive, A congruent to B congruent to C, A is congruent to C. Alright? So let's complete each of these statements. We can do it. Alright. If P is congruent to R, and R is congruent to A, so if P hooks onto R, and R hooks onto A, then P is actually hooked onto the caboose of A. All right. If X is congruent to N and blank is congruent to Y, X is congruent to Y. So X hooks onto N, and we need something to hook onto Y. N did, we'd be all set. This is our transitive one. If L hooks onto T, T to blank, then L to Q, T to Q. Yay! Let's try one. Another proof. That's a weird face. Alright, let's print. Print. It didn't work! Alright, write a 2-column proof. Alright, I kind of already showed that. I don't know if I was supposed to. Okay. First step is always given. I'm going to write that right now. Alright. So we're given A, B is congruent to CD, and we want, what we're looking for is we want to show that AC is congruent to BC. Alright, I think I can do that. And I take my given and I copy that down as my first step. So I said they're congruent, and then I say their measures equal. That's property, that's congruence. Sorry, I'm symbolizing it. Property of congruence. I'm not going to write it out every time, and you don't have to either. Don't tell our teachers this because some teachers make you, and I'm sorry. BC equals BC. So BC equals BC. Well, it's itself, it's looking in a mirror, like Justin Timberlake, so that is reflexive prop of equality. Alright, so now they equal each other. And down here, we add it to both sides. So when you add something that's the same to both sides, that is your addition property. Alright. So now we end up with AC equals BD. What? How did we get that? That's silly. What in the world? AB plus BC equals AC. Because, do you guys remember a long time ago we learned a property that's coming up again? The segment addition property, where its segment is equal to the sum of its parts. AKA, I take the two small parts, add them together, and I get the big part. You put that in your proof toolbox. Alright? And AC is congruent to BD. And that's, again, if they're equal measure, then that's a property of congruence. Alright, don't be afraid to ask questions tomorrow. I know you guys will.